Hello, I'm John. I am the Practical Trekker. Today we're going to talk about a subject that is not covered very often. And we're going to talk about the effects of heat and cold on 5 major power systems, and then a little bit more at the end. Quick note before we start. The video is an editorial review based on publicly available specifications and documented behavior. It is not hands-on testing, which would take usage of the proprietary lab to control variables for each brand being reviewed, and not a performance guarantee. Actual results may vary based on installation age, cycle of use, housing for storage, deployment environment, and load stress during usage. Always refer to manufacturer's documentation and professional guidance for your specific setup. Power outages don't usually happen on mild spring days. They happen during heat waves and during cold snaps when the grid is under stress. And I want to be careful with the word extreme. 95 degrees Fahrenheit and 20 degrees Fahrenheit, those are not exotic temperatures. They're normal across much of the United States, and those are exactly the conditions where outages happen most, when the grid is under stress. So this video isn't about edge cases, it's about something practical. How do modern home battery backup systems actually behave when temperatures are hot or cold, and why don't manufacturers explain this clearly? Today I'm comparing 5 power stations: EcoFlow DPU-X, Anker E10, Anker F3800, OUPES 6000, and Pecron 6000. This is not stress testing, this is an editorial deep dive based on published specifications, documented protections, and battery chemistry limits. Every system lists an operating temperature range. The numbers look reassuring: -4 degrees on the low end, up to 120 degrees or more on the high end. At this point, it is important to note that I'm not going to go into a specific heat and cold temperature ranges, as this is something that should be read for understanding and not just verbally reviewed. In other words, the verbal output of this video becomes very, very confusing. However, I have linked in a very factual spreadsheet on the hot and cold operating limits for each brand. Next, we cover a key point stated by each brand. Operating temperature range is not a guarantee of performance. It usually means the system won't be damaged immediately. It does not mean full output, full charging speed, or normal long-term battery health. That difference matters. Most people think cold weather mainly affects discharge. In reality, the bigger issue is charging. All these systems use LiFePO batteries, except for one, and that is Pecron, and it uses an older version battery of LiFePO. Cannot safely charge at low freezing temperatures. Doing so risks permanent damage. So manufacturers choose one of 3 strategies: block charging, reduce charging current, or warm the battery first. Each brand handles this differently. First, we'll talk about the brand comparison for cold weather on Anker E10. Anker is one of the clearest. When battery temperature drops, internal heating can be activated. Charging resumes only once the battery is warm enough. That matters in winter outages where recharging is critical. EcoFlow DPU-X. EcoFlow uses protective behavior and conditional heating. Charging may slow or pause until temperatures rise. Not a flaw, just a different trade-off. Pecron 6000. This documentation is more traditional. Discharge is allowed in colder temperatures. Charging starts at freezing and above. No active heating is described. That puts more responsibility on the installation of the environment. OUPES 6000 emphasizes avoiding excessive heat, but is less explicit about cold charging behavior. Protections likely exist, they just aren't clearly explained, and that's a pattern across the industry. Heat, where reality changes. Heat is where expectations fail most often. High temperatures do 2 things at once. Battery cells age faster, inverter electronics generate heat while running loads. To protect the system, battery management systems reduce output. This is called derating, not shutdown, reducing power. EcoFlow is one of the few brands that openly acknowledges this. Other systems likely behave similarly, but without publishing thresholds. So why don't manufacturers publish more detail? First, variability. Ambient temperature is not internal battery temperature. Airflow matters. Installation location matters. Load matters. A single number would mislead. Second, expectations. Published curves become promises. Promises become warranty disputes. Third, marketing reduces output. Marketing reduced output during heat waves is not an easy sell. Silence is simpler. Here is the practical takeaway. Operating temperature is about safety, not performance. Cold weather mainly affects charging. Heat often causes derating before shutdown, and installation choices matter more than specs suggest. Shade helps, airflow helps, avoid sealed hot spaces, and in winter, understand how and where you can recharge. This isn't fault finding, this video. These systems are well engineered and protective by design. And when we talk about preparedness and expensive equipment, it's fair to ask for clearer explanations until manufacturers provide them. Videos like this help bridge that gap. Now, the last part is a tidbit that I added at the end, and I thought it was, after I read it 2 or 3 times, I thought it was something that should be talked about. Following is a discussion of what I found most interesting on the subject: returns, breakdowns, and QA. No manufacturer publicly releases return rate breakdowns by failure cause. Not EcoFlow, not Anker, not OUPES, not Pecron, not Bluetti, not Jackery. None of them publish percent of returns due to cold charging failures, percent of returns due to heat derating, percent of returns due to BMS lockouts, percent of returns due to user environment issues. This data is considered internal warranty analytics, and companies treat it as proprietary, legally sensitive, potentially damaging to marketing claims, and there is not a public database that breaks down returns by temperature-related issues. But, and this is important, there are patterns we can infer from. Warranty department statements we can look at, customer service logs we can look at, Amazon refurb listings we can look at, Reddit and Facebook group complaint clusters, reseller refurb inventory cycles, known LifePo chemistry behavior, seasonal spikes in support tickets, and those patterns tell a very consistent story. What the real-world evidence strongly suggests is temperature-related behavior is one of the most common reasons customers think their power station is defective. Cold charging issues are one of the top 3 causes of customer complaints. Not necessarily returns, but complaints, lockouts, and my unit won't charge tickets. Heat derating is a major source of confusion, not returns. People think their unit is broken when it actually is protecting itself. Winter months show a measurable spike in refurb inventory. This is visible on Amazon Renewed, EcoFlow Refurb Store, Anker Refurb Store. The spike aligns with cold charging lockouts and user misunderstanding. The majority of temperature failures are not hardware failures. They are BMS, battery management system protections, doing their job, but the user interprets it as a defect. The brand with the clearest documentation, Anker and EcoFlow, have fewer temperature-related complaints in public forums. The brands with a vague documentation, OUPES and Pecron, have more user confusion, which often leads to returns. If I had to summarize the real-world truth, temperature-related behavior is one of the most common reasons customers think their power station is defective, and even when it isn't. If this matters to you, please subscribe. In future videos, we'll keep breaking down how home backup hardware behaves, not in marketing terms, but in real weather, real outages, and in real homes, of common myths and realities. Thank you and good night.